So we have intermolecular and we have intra. So let's start with intra. What are the intra forces? So bonding, right? It's bonding between atoms. So intermolecular forces are what? They are weaker. Yeah, in between molecules. They're the things that bring those molecules together so that when we see a bottle of water, it's not just the one atom, we see them all together, they're interacting with each other. Okay? Like Jill said, they are weaker than bonds. Because bonds have what? What has taken place in a bond? Electrons have moved somehow, whether they're transferred or they're being shared or they're in metals and they are mobile electrons that can move freely. Where the stronger pieces that we have here, we said that these are our bonds or our intra forces, and then these ones are our inter. Okay. Somebody in my afternoon class yesterday, guys, they asked, how do you know the difference if they abbreviate IMFs? Right, so you see me abbreviate that a lot. How do you know if it's inter or intra? If you see the term IMF, guys, just assume it's intermolecular forces. These are, the bonds are intra, but we don't really refer to them as intra often. We're just referring to them as covalent bonds, ionic bonds, and things like that. So if you see IMF, assume they're talking about intermolecular forces. Remember, guys, a hydrogen bond, is that an actual bond, meaning like electrons? No, it's the force between particles. For hydrogen bonding, what elements have to be present?
Hydrogen, oxygen.
Fine. Fluorine, oxygen, and nitrogen. So it's hydrogen bonded to one of those three elements, and it's those interacting. So like HF, water, NH3, something like that. Actually, that one doesn't have it. So anyway, you get the idea. It's got to have those elements in there. Okay? So let's talk about what happens to the physical properties if those forces increase. Okay? So if our IMFs will increase, meaning they go up, all these other physical properties are going to change. Boiling point's going to go up, meaning those particles are going to be held together more and more strongly, so it takes longer for them to escape into the gas phase. Melting point, likewise. So going from solid to liquid, they're held together more tightly, so it's going to take longer for them to change phase. Heat of fusion is going to go up because it takes more energy to break them apart, just like heat of vaporization would go up. Now, the last two are interesting, and we kind of talked about it last week, so I'm going to let you guys jot this down, and then we will talk more about it. They're going to flip. So if it decreases, guys, it's going to flip. Think about it. What are intermolecular forces doing? They're holding things together. So if you have strong intermolecular forces, all of these properties, guys, are going to go up. Think about it. What's happening at the particle level? To separate them, more energy is required. All of these pieces are looking at that. The first four, melting, boiling point, heat of fusion, heat of vaporization, you're adding energy in. If they're stronger, those are going to go up. If they're weaker, that means they're going to go into those things easier, less energy, so those would go down. Now, evaporation rate, guys, and vapor pressure. What is evaporation? Liquid gas, but it's not at...
It's not throughout the whole thing, it's on the surface.
Right, it's on the surface, and it's not at the boiling point, okay? It's happening just when something's just on, like a desk, okay? So evaporation rate's going to be lower because, again, those forces are holding things together more. Vapor pressure, that's the pressure that happens from where you have a liquid and a gas in a container, and it's going to go down because not as much is going to escape because, again, they're being held together tighter. That's the big idea you want to remember here with IMFs. Yeah, we can talk about what they are and all the specifics, but we're going to try and keep it simple as we go along. So, intermolecular forces versus temperature. They become more important as the temperature is lower. Okay? Low temperature, guys, low evaporation rate. High temperature, high evaporation rate. Should make sense to us there when we think about it. Because what does temperature measure? Kinetic energy, the movement of the particles. So if the particles are moving more, all right, they're going to evaporate. They're going to get in that gas phase much more readily. Okay? If the temperature is lowered, they're going to be closer together. They're moving slower, so you're going to have lower evaporation taking place. Okay? Intermolecular forces are stronger when things are colder. Okay? They are weaker when things are hotter. All right, NH3, hydrogen bonding. Okay, when you have just an element by itself, guys, remember if it's nonpolar, it's just going to be dispersion forces. So nonpolar here, nonpolar, dipole means it's going to be polar. Hydrogen bonding is an extreme case of polar, of dipole. Dispersion again is going to be nonpolar. And polar there because, again, just with its definition, dipole means that it's going to be polar. Zach?
Why is it called dipole? Why do you need two?
Because, think about it, you've got two poles on those, two of them that are bonding together. So remember, these are intermolecular forces. So you've got one dipole interacting with another dipole. So that's the force between two separate molecules. That's why which each of them have a dipole in them, and they're coming together. Does that make sense? So it's like you've got HCl interacting with HCl. If we drew like circles around, even though this doesn't make sense. Here's your partial positive, partial negative. Here's the partial positive on this one, partial negative. That's why it's you have a dipole in each of them, and that's the interaction. Does that make sense? Okay. So, we will see as the year progresses, guys, what type of questions you're going to see on the Regents exam. I'm going to start researching that to figure out just how in-depth we need to go. So right now, it's giving you guys the information, and then as we go and as we review later on, we will see kind of how far we need to go into it. I don't want to stress you out too much about it, but give you the information that you need. All right? So just as a overall kind of a summary of your forces, guys. Intermolecular, these are the three forces that we have: dispersion, dipole, hydrogen bonding. Intramolecular, you've got covalent, ionic, and metallic. Okay, kind of keep them separate. So this is, remember, within a molecule, and this is between molecules. Okay, it's between them.